Hi, I'm Alex Thomas. I'm Principal Data Scientist at WiseCube.
Hello, I'm Martin Vladimirov. I'm an intern at WiseCube.
And today we're going to be talking about a new project we have, the Experiment Tracker. It's a tool we use to track early stage AI ML experiments. So, a little bit about us. We both are from WiseCube. So WiseCube, we're building knowledge graphs technology in the biomedical field. And this tool actually became very useful for us to track some experiments that we're doing with LLMs. But let's get more into that. So, why do we need a new tool like this? Well, first of all, we do need to do AI ML monitoring. It's definitely better to do it at all stages of the development cycle. Monitoring during model building proves, as we see here, we can get reproducibility, better coordinate among people doing experiments, as well as being able to do the experiments in a more organized way. During monitoring at production, let's just identify if something's changing in the data. This is often very important, for example, in fraud models or any sort of user interaction model, as well as validating assumptions that we're making. And of course, as every software engineer knows, monitoring in production lets you find bugs better. But early on, what do we do? What if we don't have a metric? Then how are we going to monitor the quality of our model? What if we don't have much of a label set? How do we measure the quality? How do we even, see whether we're making progress? How do we monitor while we're still defining the problem? So these are some examples of projects that let you monitor your experiments, but they sort of are assuming you have metrics, assuming you have a label data set. So what do we do before that in the earlier stages? So let's look at some examples and comparisons between early stage and later stage experiments. So early stage, we have traditional ML and deep learning tasks, but we don't really have a way of measuring it because it's just So we don't have a good way of measuring it because maybe we don't have enough labels, or labels are difficult or expensive to obtain. This actually is really common to happen in the biomedical domain, because sometimes the labeling of an answer for, let's say, a question answering system or for predicting something from an input actually requires an expert. You can't simply farm it out to any sort of crowdsourcing. So it can be timely to get an expert on hand and very expensive to do so. So you may have to rely on either lower quality or much fewer number results in the beginning. Whereas in traditional ones, you generally have your development process begin assuming labels and defined metrics. Another early stage example is a product feature where it's in the information gathering phase. So some stakeholder, perhaps a product owner, comes along and says, "Oh, we want to add this feature," and talks to the data scientist, but we're not really sure how to implement that feature, how to measure that feature. And they don't want to invest a lot of resources in it until there's a clear plan for development. So how do you measure those experiments? Versus in the latter stage, you often have in an experiment, you have the requirements and you have committed resources to set up dashboards to make sure you have all the label results. And then this is sort of the example that led us to creating this project, which is if you have an LLM-based solution, but there's no clear evaluation. So in our situation, we are looking to translate a natural language into a graph query language, but there is no data set out there for that. So that means that we're going to have to combine both someone who knows the data set, the data structure itself well, as well as perhaps a domain matter expert to consult on it. So labels are really hard to come by, and we're not even sure what would be the appropriate metric. Lots of experimentation needs to be done on that. But this contrasts with latter stage ones where it's an LLM-based solution where you have lots of examples, hopefully where you're maybe giving it to the LLM for a few shot learning. So we see here that there's these early stage situations where traditional monitoring and measuring don't really work well. So we have a problem where we have few resources, we lack definition, and small amounts of data. So that means we need a lightweight tool. If you have very few resources, that means you're probably not going to be approved to like spin up a separate server or to spend a week configuring a complex system. So it needs to be really simple. So we just have a simple React app. For lacking definition, that means you need to have easy access to the data. It needs to be flexible. You don't need to have, you can't afford to have to learn a new system to rebuild your data every time you have an update. So that's why we have a simple configuration with the app, and we're using Google Sheets to store the data. It's interesting, and I find it somewhat ironic to note that the same reason why tracking your data in Google Sheets is not good in production is actually really great at this early stage. All the things that are bad later on are good here. And also small data. Again, Google Sheets is a way to do that, because we don't want to have a complex tool that's trying to do everything for us. Nope, just a spreadsheet. The data scientist can go and figure out how to manipulate the data as they need, and we just display it in this tool. So I think now I hand it over to Martin.
Yep. All right, so for the experiment tracker overview, this is a very simple, easy to use tool with just a few easy steps to get set up. So to begin, the user would supply a CSV spreadsheet, and from there, they can start tracking their experiments. It will serve as a tool for reviewing label results from published Google Sheet spreadsheets, and the user can select different runs and sort the tables based on different fields, and I'll explain as we go on. So for each one, there's going to be a runs table and a results table. Now, for the overall runs table, there's going to be 5 mandatory fields, those being run name, run date, score name, score, and G drive URL. So the CSV file will be listed under the G drive URL, and once you click on that button, it will open the results table for that specific run. And for each runs table, you're allowed to include as many optional fields as you'd like, and based on what you see fit. And I'll explain how you do this later on in the slides in the config.js file. As for the results table, it's similar as it has 4 mandatory fields for the individual run, one of them being ID, the other being input, result, and label. And here, additionally, you can choose to add as many optional fields as you see fit, and this will also be in the config.js file under optional fields for results table. So how to set this up? So it's actually quite trivial. You would navigate to the Google Sheets spreadsheets, and you'll click on the file, and then you'll go to share, and then under share, you'll see a publish to web. Make sure to select one sheet, not the entire document, and select the CSV from the list. And once you have that link, you'll simply need to paste that link in the config.js file titled runs table CSV file. As you can see, here is where you're selecting it from the individual run, not the whole document, like the one sheet. And here's just another screenshot, like displaying it clearly. And this is the config.js file. As you can see, the first one is for the runs table. So here's an optional field 1, optional 2. You can either choose to remove them all or add as many as you'd like. They're separated by commas, and each optional field is in quotes. So you can add as many as you'd like for the runs table, the results, and the CSV file will be in the runs table CSV file. In order to build and run it, it's a simple Docker command, docker run -d-p port and then X tracker. All right, and here we're going to go over a quick demo. Alex, I think you're muted.
Okay, sorry about that. So here we're gonna go over the sheet that that we're gonna want to display in the tracker. So we have all the data here in one document. So we have the runs here. The runs file is going to have sort of the description of the list of all the different ones we've done, and then we have the individual results in the different tabs. So as we sort of just showed in the slide, you would come here, you would go to share, publish to web, and then yeah, you'd want to select runs, select CSV. And similarly, when we're filling out the fields for G Drive URL, you would just select one of your results and similarly share that sheet as a CSV as well. So we have the sheet here. Let's go over and see what we need to configure. So I actually already have the configuration done. But I'm going to show sort of like what you get. So you go into source here and you get to config. So this is the config that we have right now. And they will show you what it looks like when you initially get the project. We have this blank version right here. So it comes in, we have some like example fields, and then it's blank here. And if you leave it blank here, it'll give you a nice informative message that you need to go set, the CSV. So yeah, here we're gonna add the description field to already the list of required ones for the runs table, and for the individual results we have types, precision, recall, and F-score. So it's real quick. Go now and launch the service. So we've actually already built the Docker. So I'm just gonna run it like this. Okay. So let's go over here. So yeah, we have our set to run already. So let's go ahead and get one of the other sheets. So here we have one of their sheets. We can sort the runs as well by the fields. So right now they're in the date that they were retrieved by. Let's go ahead and sort by score. See what happens. And we see we get the top score one at the first. So you can sort this one. Yes, the luck of live demos. Okay, so yeah. We have the results shown here. And yeah, we can also similarly sort by the different fields here. We can also search for values. So let's go try and look for something. Yeah, let's just go ahead and we'll search for this. And we'll search under label. And yeah. So so yeah, so you can search and you can filter by it. So yeah, it's really a simple it's a simple way to track all your early stage experiments. Here, the sort of example we're going with is just like a basic NER based LLM extraction. But yeah, cool. So I guess that's what we got for the demo. Let's go to Q&A. So how do you transition from the early stage to the latter stage of tracking? So yeah, that's it. So what you want to do is we talked about in the slides. Once to early stage, you don't have either labels or you don't have the resources to do the full level experimentation. So once you do get a good amount of labels, you sort of want to deploy them in whatever of the latter stage frameworks that we discussed. You can deploy that, and with the way of keeping track here in the experiment tracker, all the data you're going to need to sort of set up like the initial view of the data in these other trackers will already be there. You have the tables, you'll have the metrics. I would recommend sort of like switching over once you get to that stage where you first want to like share the results with perhaps like more business people or external people. Um, yeah.
No, you're allowed an infinite number of runs allowed in the runs table. So yeah, and there's also an infinite amount of optional fields on each one. If you want to display 0 optional fields, if you want to display 5, that's totally up to you.
Yeah, so we saw, we found this project to be a nice lightweight project to help with this early tracking. Yeah, it doesn't require much or really anything in the way of infrastructure. Um, and yeah, it's really easy to set up and deploy. So this is actually a good question. So I would recommend if you're dealing with clinical trials, is first of all, it's going to kind of depend on like what your on what your project is. So what are you trying to do? Um, but the good thing about this is like you could just display the text or the different fields from clinical trials. It sort of depends on whether you're working with the free text of clinical trials or the structured data. So you can have that in the spreadsheet and obviously easily add it in as optional fields, and then just begin tracking your experiments and exporting them to the CSV that you're getting the data from. So yeah, I think that these types of data sets with mixed text and structured data, this is a great tool for. Well, so as far as we're dealing with private data, so what we're working with here is that it is sort of expecting you to be working on Google Sheets. So whatever data you're comfortable putting on in your in your Google sheet in your Google account, your G Drive, it'll respect that. It doesn't do any sort of like additional exposure of the data. Um, you can like obviously with it when you publish a CSV, you can configure who can access it. Um, but yeah. Yeah, one of the things at least. Oh, have you tested it? Tested the tool with real life data? Actually, yes, we do use this for tracking. If you see our previous webinar, we do natural language to Sparkle modeling, and that is a really solid example of an early stage one because there's no, fresh out the box labeling set for that. So a lot of this is sort of like implementing changes to the algorithm and then getting the results and having someone manually go over them. So yeah. Yeah, so one of the things I was mentioned is I remember working at previously at a large software company, and one of these examples that I gave is for an early stage one, which is they want you to build a particular feature for the product, but they don't want to give resources to it yet, and so you have to figure out like how that's going to work, how it's going to be measured, in order to plan it out. I was actually in that situation, and um, it actually is kind of tricky because your product manager wants to know what this early fact finding is doing, but it might be a little bit difficult if you have a complicated spreadsheet with hard to understand from a non-technical point of view, hard to understand references to different data. So I wish I would have had a tool like that back then. Okay. Well, I want to thank everyone who has come here, and thanks for the great questions. And we will be making the repo for this public later today. So watch the WiseCube AI GitHub account. Thank you.
Cool. Thanks. Thanks, guys.